Hi students, in this lecture I am going to discuss problems based on refraction. Let us see first one. An object is placed in front of a slab of thickness 6 centimeter at a distance 28 centimeter from it. Other face of the slab is silver. Find the position of final image. Okay, let us see how to solve it. Right, first make a diagram for the given data. This is now slab. Its one face is a silver. Its one face is a silver. And for this mu value 1.5, its thickness is now 6 centimeter. And we are placing an object at a distance. It is 28 centimeter. Okay. So we have to see the final image location, right? So where we get final image. This is now object. Let us take it as this is A and this is B. Right. First of all, light rays they fall on this face, right? Then they're having refraction. Students, if you remember, we have discussed in last lecture regarding upper and depth, right? Now this is object which is in air medium entering into this slab medium. That means light rays traveling from rarer to denser medium, right? In that case, this distance AO appears to be more than AO. And how much means? It will be mu times, right? So I'm writing here mu times of AO. Mu value 3 by 2 means 1.5. AO value 28 centimeter. This is here 14 times. This is now 42 centimeter. See meaning of this. For this face, this is now object. For this object, image will be at a distance 42 centimeter from this face. How much we got? 42. Let us take it as I1, image 1. Okay. So I can write here distance AI1. AI1 is how much? 42. Okay. Now you can see rays after refraction, they fall on the mirror. Okay. That means this image I1 is acting as object for the plane mirror. I am repeating. Light rays after refraction here, they incident on the plane mirror. Its meaning is this image I1 is acting as object for the plane mirror. And you can see distance of this image from the plane mirror. AI, that is 42. This is now 6. That means BI1. BI1 is equal to 6 plus 42. That is 48. Right? So this is now distance of this image. Now this is acting as object for the plane mirror. And we have learned that distance of object from plane mirror is equal to distance of image from the plane mirror. That means it will be forming image behind the mirror. Distance how much? 48. So I am showing here. This is now I'm taking as I2. Okay. So distance how much means BI2. BI2 is equal to 48. So why 48 means? Because distance of image and that of object from the mirror are same, right? After reflection, rays are falling on the front face, right? Its meaning is that this I2 acts as object for this face. I am repeating. Light rays after reflection are incident on this face. Its meaning is for this face, this image I2 acts as object. Okay. Therefore, its distance from A. Its distance from A means AI2. See how much? AI2. BI2 48. So 48 plus 6. It is now 54 centimeter. Okay. Now you can see rays are traveling from slab to air. Means from denser medium to rarer medium. Then this AI2 appears to be 1 by AI2. So 1 by mu times of AI2. See this value how much? This value is now 54 1 by mu. It is 3 by 2. 3, 54, 18 times. It is now 36. Right? That means because of this refraction, finally image will be at a distance 36 from A. So 36 from A. So distance how much? 36 centimeter from A. It is left of A. Means it is behind the mirror. If you ask from B, it is 30 centimeter from B. It is behind mirror. Behind mirror means it is virtual, right? So this is the location of the final image. So I1 because of refraction, I2 because of reflection. Next, finally I3. I3, how much it is now? BI2 48. I3, it is somewhere here, I3. Okay, that this is what? AI3. And this is now BI3. So finally, image is a form. Finally, image is formed behind the mirror. Distance is 30 from B, 36 from A. Okay. So how to get idea means first refraction. So image because of this. Next reflection. Image because of this. After reflection, they fall on this surface. Again refraction. So finally, okay. And remember, whenever we are using distance mu times of AO or 1 by mu times of this distance, we are taking here assumption is instant light rays are paraxial. That means angle of incidence, angle of refraction, both are very small. Okay. Let us see next one. Let's see the question. A light ray is incident at an angle of 45 degree with the normal to a root 2 centimeter thick plate given mu value to find the shift in the path of the light as it emerges out of the plate. So this question is taken from Hetsi Verma. We can see light ray given angle of incidence and given thickness of the plate and mu also given. Find the shift in the path of the light as it emerges out of the plate. Okay, right. So let us make first of all diagram for the given data. In fact, this is known as lateral shift. This is known as lateral shift. See what he is asking here. Right. This is now slab. This is a slab. Let us take here normal to the slab. Normal to the slab. Let us take its thickness is T. Thickness is T. Now light ray is incident. Light ray is incident. This is now instant light ray. Angle of instance it is I. Now here having refraction, right? Refraction. Next, again, if you see observe here, when light rays they come outside, it bends away from normal. Means it is like this. Okay. Now see carefully. Let us write. Okay, this is angle of refraction R. Here and here. These two boundaries are parallel. This angle of refraction becomes here angle of incidence. It is R. Okay. Let me write here Snell's law for air and slab boundary. Here air mu1 that is 1 sin I that is equal to this is mu into sin R. Okay. Next coming to slab and air. Now this is angle of instance. So mu into sin R equal to here. You can observe carefully mu value is 1, right? Mu value is 1. Then this value must be equal to y. See carefully. I am writing mu sin R equal to 1 into sine of this angle. Okay. So since these two boundaries are parallel, here what we can say, this angle is equal to here angle of incidence. That means this instant light ray and emergent light ray both are parallel. I hope you are getting this point. Instant light ray and emergent ray both are parallel. Its meaning is there is no deviation. There is no deviation. It is just shifted. Let me draw a diagram here. If there is no slab, this light ray is supposed to continue the same path. Supposed to continue same path. Now this emergent ray is a parallel to the instant ray, parallel. And you can observe here, if I draw normal from this point to the instant ray. Okay, let me take it as this is A, point A, this is B, C, and D. In this CD, CD is known as lateral shift. See the meaning of the sentence lateral. Lateral means it is normal or perpendicular. That means this is now shifted normal to the initial direction of motion. Get the point. There is no deviation. It is just shifted. It is just shifted normal to the direction of motion. This is now direction of motion, shifting normal to that. That's why CD is known as lateral shift. Okay. Now we have to focus how to get this one. So remaining is just geometry. Let us see carefully. We want to calculate CD. So we want to calculate CD. You can see in this triangle ACD, this angle, total value equal to y. This angle is now I minus R. To find the CD, see what we can do. First consider triangle ABC. In this triangle ABC, AB is known. We want to get AC because if AC is known, we can find CD. Okay. And in this, AC is nothing but length of the path inside the slab. Okay. Means if question is asked like distance traveled by light in the slab, it is AC. Okay. Now we get AC. AB is known. So I'm taking here cos R, cos R equal to extent side is AB, that is T, thickness of the slab upon hypotenuse is AC. Okay, that means distance traveled by light in that slab is it is equal T by cos R. Okay, next we want to find CD. AC is known. AC is known. Then see what we can do. AC is now hypotenuse and CD is now opposite side. So take here sine of I minus R. Sine of I minus R that is equal to CD, which we want to calculate CD upon AC. So from this lateral shift, CD is equal to AC. AC is now T by cos R into sine of I minus. Okay. So this is now expression for lateral shift. So in this T by cos are known as distance traveled by light in that slab. And we are knowing I minus R, that is deviation, right? Inside the slab. Deviation how much means? It is equal to I minus R, right? And here important point is when emergent ray comes outside, if question is asked like what is deviation? Deviation is zero, okay? And this deviation is because of refraction at this boundary. Okay, this deviation is because of refraction at this boundary. Finally, when it comes outside, finally, when it comes outside, there is no deviation. It is only shifting normally or shifting laterally, and that value is given by. Okay, now in our problem, thickness is given, right? T value is given and mu value is given. So since mu value is given, we can find remaining all values. Okay. See carefully in this what we want. Mu value given, thickness given, right? And see what about angle of instance 45. Angle of instance 45. Right? Mu value is given 2. Okay. This is now here. So I can write mu 1, that is 1. Sin I, sin 45, that is equal to mu 2, sin R, right? That from this we are going to get the value of sin R, right? Sin 45, 1 by root 2. From this, sin R is equal to, it is 1 by 2 root 2, right? It is 1 by root 2 by 2, 1 by 2 root 2. Next, from this we can find a cos R, right? We can find a cos R, thickness given. And from this we can find R value, then I minus R, okay? Like this, we can calculate lateral shift. Okay. Let us see next problem. This is now based on the previous problem, that is lateral shift. In that lateral shift, we have seen when light ray emerges out of the slab, there is no deviation. See carefully once. This is a previous IIT problem. A diverging beam of light from a point source S having divergence angle alpha falls symmetrically on a glass slab as shown. This is point source. Light rays are diverging from the point source. This is now angle of divergence alpha. The angles of incidence of the two extreme rays are equal, given I and I. If the thickness of the glass slab is T, glass slab is T, and its refractive index is N, then the divergence angle of the emergent beam is. So just now we have discussed when this light ray comes outside. I will draw a diagram once again. So let us make a diagram. This is now slab. There is a 1 point source. Given angle of divergence, that is alpha. Light rays instant like this, keeping arrows there. Now let us focus only one light ray. Since they enter from air to slab, means denser medium, they bend towards normal like this. Next, if you take normal here, they bend away from normal like this. Now what I am saying here, let us take this as A. Okay, it is A and this is B and this is C. Now what I am saying here, SA, that is now instant light ray, and BC is emergent ray. This emergent ray is parallel to instant light ray. This point just now we have discussed in the previous problem, right? Lateral shift. So when this is a parallel to this, same logic coming to here also. Light ray coming like this, next moving away from normal like this. Let us take it as this is a D and this is C. Now DE is a parallel to SF, parallel. So this is a parallel to SA. This is a parallel to SF. That means if I'm extending these two back, if we extend these two back, then see what happens between those two also. Angle same. Getting it? Because there is no deviation. It is only shifting normally. Okay. So basing on the same problem. This is a previous IIT problem. So answer is, it is B. It is option B. Okay. Let us see next problem. See what is given. An observer can see through a pinhole, the top end of a thin rod of height h placed as shown in the figure. The beaker height is 3h and its radius is h. When the beaker is filled with a liquid up to a height of 2h, he can see the lower end of the rod. Then the refractive index of the liquid is asked for 2 marks in 2002. Let us see how to start the problem. Right, first make the diagram given. right? Having a rod, right? Rod is given here. Rod of length h. This is the rod. This is now rod. Height is h. So total height is given 3h. Total height. And rod height is h. Now a person seeing the top end like this. So light rays coming from the top end reaching his eyes. Okay. Now what he is doing is, this is a field with a liquid up to a height of 2h. This is h. Let us now, so height is up to a height 2h. This is 2h. Then he is able to see the bottom end of the rod. That means I can draw here from this point. Let me draw once again. Right now he is able to see the bottom end of the rod also. Take a line from that point like this. So light rays coming from here after refraction reaching his eyes. Okay. Now this becomes angle of incidence and this becomes angle of refraction. Right. First of all, focus what is I and what is R. So I think directly we can say R value 45. See how it is a 45. So when you are taking the first part, okay, from here, this total height is given 3h. This is now h. So remaining how much? 2h, right? This is 2h. Now you are given this base is now 2h, right? This is a 2h. This is a 2h and this is a 2h. That means this angle how much? It is a 45. Okay. This angle is a 45 means this also 45. That's why R value 45. Okay. Next, coming to I value. Coming to I value, let me take this as A, this is a B, and this is C. From diagram, we can say AB value that is equal to H. Okay. And BC value is 2H. Right. Then C, we want to use Snell's law, that is a mu of the liquid sin I should be equal to, it is entering into air, so it is 1 into sin R means sin 45. So we want sin I value. Okay. Sin I means what we can write AB, that is H. H hypotenuse, how much? AC value will be square root of H square plus 2H whole square, right? Because BC 2H and AB is H. So this is now 4 plus 1, 5. This is a root 5 into H. So mu, this is now how much we can write? Sin I is equal to H upon AC value root 5H means 1 by root 5. 1 by root 5 that is equal to 1 into, it is 1 by root sin 45. From this we get mu value, it is a root of 5 by 2. Okay. So it is mainly based on geometry. So first writing the given condition, directly able to see. Next, after filling liquid up to a height of 2h, now able to see the bottom end of the rod. So now taking the geometry, we can get the answer. Okay.